MOT 135, Chapter 11, Lymphatic System, Part 2. I'm going to try and summarize most of this. The defenses it talks about that we have with immunity and our bodies. So we have non-specific, which I'm not going to go into in too much detail, but you have a couple of pages to read about non-specific. But in summary, we have external barriers, which are things like the skin and the mucous membranes, which we've already talked about, and they produce inflammatory responses. If you poke a splinter or something gets into the skin, we will have that response, and that's the white blood cells basically helping to fight the infection. Inflammation, antimicrobial proteins, fever, and other active attacks are our responses to these other invaders. They are non-specific. They will act the same way whether you get hit by a splinter once a year or get hit by a splinter once a week. It will do the same thing over and over again. It won't remember anything. It will just say, oh, that's my response and this is what I do. So it isn't being picky. Then there's specific. There's two types. There's humoral and cellular mediated specific immunity. And that's to some invaders that get deeper into our body, deeper than the external barriers. Usually prior exposure is needed to these pathogens. It starts with an APC, antigen-presenting cell. Antigen-presenting cells can be B cells, they can be macrophages, they can be dendritic cells, they can be any cell in the human body. So an APC, antigens can be presented on many different types of cell. Figure 11.15 is actually a very good visual on how the cells, what they do with these foreign invaders. What does it do with it? It takes it in, it encapsulates it, it brings in a lysosome with enzymes to break it down, but it keeps it within this little capsule, and then it throws out the debris at the end once it's broken it down, broken its chain so it can't react anymore, but it keeps a little piece of it. And this little piece is called an epitope, and this is a little display, a little poster to say, I've tried this, it's not good, okay? Or I've tried this and it is good. Sometimes the epitope can actually be self, okay? So some body cells can produce epitopes, little banners, posters, whatever, to say, this is me. A foreign epitope will produce, and they'll go, I've tried this and I'm not sure what it is. Okay, so it's just presenting it. It's just saying, hey, look at this. So these are little flags that go up, and they're either good or bad. In humoral antibody mediated, it's only the B cells that are the producers of the antibodies. The B cells make the antibodies. The B cells like to go around and sample their environment, a bit like you wandering around Costco or Sam's Club and trying a little piece of what's on offer. And as we see by 11.15, the lysosomes contain the enzymes to eat and break down the antigen particle on a chemical molecular level. It keeps a reminder of what it's tried as a billboard. So it's gone around Sam's Club and it said, I tried that. Here, look. I tried this. So the MHC, the protein, is the billboard, and the epitope is the poster that goes on the billboard. So many cells have MHCs, but it's the epitope that is the poster that goes on there, and that can either be self or foreign. Now remember the T cells. T cells go to school, remember, in the thymus before they mature. While they're in school, they are taught to ignore self epitopes. Okay, they're taught to ignore that. Any T cell that doesn't ignore it basically gets killed. A little harsh, but it gets killed because they're not supposed to react to self epitopes. Okay, but if it's foreign, then they know what they have to do. So the T helpers that are floating around, the mature T helpers, come out into the bloodstream and into the tissues, and they either ignore the self, which is what they're supposed to do, sometimes it goes wrong, or they react if it's foreign. This is part of the recognition stage. Okay. The T helper, if it reacts, it goes over to the B cell and says, hey, what you just tried is bad, and you now need to clone yourself. So the T helper is telling the B cell what to do. The B cell then clones itself into two things. It clones a lot of plasma B cells, which is to kill the current infection, and it produces a few memory B cells. As you can see on page 441, in this analogy, it's producing one memory B cell to about 5 plasma B cells. So it's producing more plasma B cells because we need to kill the current infection. But it's producing a few memory Bs because we need to remember this later on. And figure 11.16 again is good in visualizing that cloning part. This is the recognition. Then the reaction is that the B cells, the B plasma cells, go out and kill the infection, and the memories just hang around waiting for the next exposure. So from day one of exposure to a foreign pathogen, it takes 3 to 6 days to accomplish antibody production from the primary exposure, and then another 10 days for the antibodies to reach their peak enough to really get going on the illness. So this is why when we're first exposed to something, it can take quite a while for us to get over the disease, because it can take 10 to 16 days for them to reach their peak enough to kill enough of the pathogen. Once the pathogen has been killed, the antibodies, the plasma Bs, decrease. Of course, the memory Bs are still there, but the general antibodies decrease because they're no longer required. On a secondary exposure, we get the next exposure of, let's say, measles, or secondary exposure of some bacteria or other. The memory Bs will remember it, and they will reach a peak in 2 to 5 days, much faster, and they'll fight it faster before it gets a halt. Okay, so it's not that you haven't had the disease again, even if you're immune to it. It just means that you'll have a much shorter version of it, and you won't necessarily see the symptoms, because sometimes incubation periods for symptoms to produce are anything between 3 to 25 days. That's, and so we may not ever see a symptom, but our body's been fighting it. The cellular mediated is it starts with any antigen presenting cell or any other presenting cell in the body, like I mentioned before. If it's got something on a billboard, MHC. Cellular mediated is the good one that we use against viruses, that we can use against when we give injections and immunizations. We are using the cellular mediated response in this case. So the recognition part, the T helper or the T cytotoxic, both of them are wandering around in a few numbers. They react and bind to any APC that's presenting something as foreign. Okay. Now, as I've said, it can sometimes go wrong and it can attack things that are presenting as self, but most of the time it's foreign. Both the helper and the cytotoxic clone themselves, and they produce memory cells as well. They produce approximately equal memory cells to their own clones. So now we've got masses of T helpers and T cytotoxics. The T helpers go around making more, telling other people. It's like a communication system. Now there's more of them. They can go around the body faster. They can do everything in their power to react and to clone themselves over and over again. Then the cytotoxic ones are the part of the reaction. Only the cytotoxics travel, don't seek out, but they can kill the foreign antigen. So the activated cytotoxics travel and they seek out that specific foreign antigen. They have their orders, now they're going to do the job. They can also kill the originating pathogenic cell if it's a virus. Remember, a virus is the only pathogen that gets inside a cell. So you remember the cell with the nucleus and the RNA and the DNA. The virus reacts to the cell in such a way that it stops the cell from doing what it's supposed to do and tells the cell to produce itself. So it's gone in and says, no, you must stop producing this. Now you've just got to produce me. You've just got to clone me. A virus uses the cell to clone itself, and then it can go out and go into other cells and spread. Okay, so that's why viruses spread. Now, activated cytotoxic T cells can kill that original factory, as if to say, no, you've got to stop producing that, because that's the only way that it's going to stop reproducing the virus, is to be killed itself. So this cellular mediated is good against viruses. The cytotoxic cells attract natural killer cells and macrophages and more cytotoxic cells and B cells. It invites all of them to the party, and they can help clean up and attract more and more until they have defeated the enemy. Then the T memory cells produced by the recognition stage wait for the second exposure, and there are many of them that, because there's many more of them produced. So that's why when we do blood typing or blood testing to see if we're immune to something, that's what we're looking for. We're looking for the T memory cells particularly.